Welcome everyone. Thank you for joining us today's webinar. My name is Smita Kamble. I am the marketing manager at Design Tech Systems. Today we are presenting on how to improve the crashworthiness, safety and manufacturability of complex design with Altair Radioss. Today's presenter is Mr. Abhijit Kulkarni. He is the regional technical manager at Design Tech Systems. He is a graduate production engineer with more than 15 plus years of experience in new product development, design and CAE. As a part of his consultative career, he has supported several customers in various domains by adapting latest technologies in the area of CAE to accelerate time to market while balancing cost, quality, and compliance. Just few guidelines before we started. If you have any queries during the presentation, please type them into the question box in your control panel. We'll bring them up to the presenter once the presentation is over. You may also raise your hand to ask your questions personally. So that's at my end. Let's move to the technical presentation now. Over to you, Abhijit.
Smita, just to confirm, my screen is visible and I'm audible.
Yes,
Yeah.
you are very much visible. Thank you.
Yeah, good afternoon, everyone. Thank you for joining this session. And today's session is on Altair Radioss, which is an explicit finite element solver. I will talk on mostly on automotive and which about the application about the crash and safety. The agenda for today's presentation, I will take you through the company profile of Altair and Design Tech, and then directly jump onto the subject matter, that is Altair multiphysics offering for automotive. And last but not least, the question and answers. If you have any question in between, you can type your question in the chat window so that we will answer at the end. About Altair, Altair started way back in 1985. It's pretty 35-year-old company, and last year revenue of Altair is $515 million. And this company head office is in Detroit, USA, and currently we have 3,000 plus manpower and 12,000 plus customers globally, having 86 offices in 25 countries. In India, our head office is in Bangalore and having the branch offices in major metro cities. Currently, Altair is having 150 plus products. So, and most of you are aware of Altair Hypermesh, so which is our flagship product. But apart from that, over the period of 35 years, we added lot many technologies. We added various solvers and which cater to various multiphysics simulation. This is a partial list of customers, be it any industry vertical, whether it is automotive, aerospace, education, energy. So we have customers who are using our tools and technologies for various applications, not only just automotive, but they are using it for defense, DRDO application as well. If you talk about Altair Radioss, so Radioss, as I said, explicit finite element solver, and currently it is used almost 2,000 plus companies. So you can see the names, not only just OEMs, but apart from that, various tier 1, tier 2 suppliers in India. Altair Radioss being used almost in 100 plus companies. So why people are choosing Altair as a product development product portfolio? Because we have various solutions starting from data analytics to various multiphysics simulation. Of course, design modeling and visualization, which is our flagship product, which always start with the Hypermesh, where you can prepare the deck to any kind of solver. And the best part of Hypermesh is something ease of use, so where you can create meshes for complex geometries, and easily you can check the quality of the elements, you can modify it, and basically ultimately you are preparing your model good, so that you are getting the good quality results. So that is what the design modeling and visualization. For physics simulation, I will take you through the various solvers available in Altair, not only just for structural analysis. Apart from that, you can do electromagnetic simulation. So that is the acquisition. So we have been from 2011. So we acquired electromagnetic simulation. So FICO, which is basically used for high frequency electromagnetic simulation, and the flux, of course, for the low frequency electromagnetic simulation. So nowadays, if you talk about the trends which are coming into the data analytics, so that Data Watch as a company we acquired in 2018, and the best part of this, even though if you are a mechanical engineer, you don't need to have a coding language, because majorly this data analytics used by computer science engineering students or professionals. But with the help of knowledge works, you can use these tools, you can do the data mining, data generation, data pre-processing, and you can build a machine learning model on top of that. So we have 80 plus machine learning model available, and that you can use for doing the predictive and prescriptive analysis. So where, and that not only this data analytics used in manufacturing processes or financial application, but you can use it for engineering simulation as well. So what I mean to say, if you are doing virtual simulation from last 5 to 10 years and you have a lot of engineering simulation data, so that data you can use it for data preparation, and then further you can generate a predictive model, machine learning model, and from that you can do a predictive analysis without doing any virtual simulation. So that is a trend right now coming on. Then apart from that, we have high performance cloud computing solutions. So where PBS, which is a code from NASA, we acquired, and that is used for workload management. So something, you have a cluster and you want to use that cluster through remote control. So the PBS will help you to find out what are the uh, processors available on that particular hardware. You can do the job scheduling, job monitoring, job queuing, and even though once you run the simulation, you can able to check the results even though you haven't installed any software on your machine. So that is the way of high performance computing, and for that we have again two offerings. One is virtual appliance, so where you can use our cloud based services. You can fire the job from anywhere, anywhere in the place, and then you can always you can also see the results as well. And the other one is the physical appliance, so where we are actually giving a hardware with factory fitting in terms of you can we have Altair solvers inbuilt into that, and along with the PBS and PBS software. And last but not least, we have tools and technologies for IoT as well. So this is the broadest range of product portfolio right now we are having, and this can be used for various application. About design tech, as I said, design tech is a implementation partner for Altair, and we are associated with Altair from last 20 plus years in India. And currently our head office is in Pune and having the branch offices in various cities. The manpower of design tech is 750 plus, and most of them are mechanical and electronics electrical engineers, and we are among top 3 CAD/CAM CA PLM solution suppliers in India. In India, we have 2,200 plus customers which use various tools and technologies for the product development process. So now coming back to the topic of today's topic, so where the first one you can see on my slide, that is Altair simulation driven design. So basically we have divided our product portfolio into two category. One is for the design engineer. So say for example in R&D department you have a design engineers and as well as CA engineers. So design engineer basically generate a concept, doing the detailed designing, the modeling part of course, then doing the assembly drawings and manufacturing drawings, and then if they want to validate those designs, then only the CA engineer comes to the picture. But say for example, if you have a tool where you can do a quick design exploration, okay, with consideration of all complete system level simulation, so then it will be easy to freeze the concept. So that's why with that approach, these are the tools and technology used for design exploration. So starting from the left hand side, you can see the Inspire Studio, which is again a rendering tool or industrial design tool. The Inspire structure, where you can generate the quick concepts. Of course this concept generation is very important in any product development process, because after that only the design validation comes into the picture. So you are, if you are getting the right concept at the starting stage of your design, so with the help of topology optimization you can generate those concepts which are mathematically correct. So what are the input parameters required for that? You need to define a package space. A package space is nothing but a design space where you can change the design and the loading conditions. So with these two input parameters, software will run the iterations at the back end, and it will give you a optimal design or optimum material distribution. So at the starting stage, then further you can take this, you can do the detailed design validation. Apart from that, Inspire Motion, so basically where you want to do a kinematic simulation, so you have a mechanism, and this mechanism is drive through a motor. So you can consider the motor as well as the whole mechanism. So you are considering the dynamic load cases, and further you can do a complete system level simulation. For the fluid, we have Accusol, which is again included in our Altair simulation driven platform, where you can do the flow simulation and heat transfer simulation. And not but least, we have the manufacturing feasibility and manufacturing simulation solver available in Altair, so where you can do the casting process simulation, injection molding, forming, extrusion, and as well as 3D print process simulation. So as a starting stage of your design, you are not only just doing the designing, but also you are checking the manufacturing feasibility, a complete platform for design engineers. And then comes to the multi-physics simulation, so where, say for example, you want to do a complex physics simulation, so then you need to have a detailed CAE. So you starting with our complete full-fledged MBD solver, where you can do the rigid body simulation as well as the flex body simulation. And from the structural analysis perspective, we have couple of solver name as OptiStruct, and another one is Radioss. OptiStruct is basically used or used for the application where you want to do the linear, static, dynamic, modal frequency response, fatigue analysis, as well as implicit simulation. And the Radioss is specifically used for the crash safety, impact, and blast simulation. Apart from that, on the right hand side, you can see the thermal CFD capability. We have the manufacturing simulation. And at the starting stage of my presentation, I talk about the electromagnetics. So a complete product portfolio we have, which, and the best advantage of this is something you can couple these solvers at any point of time. So we are considering the complexity. So apart from that, from the electric vehicle perspective, so right now everyone talking about electric vehicles. So if you see the technology discipline which we can cover through the Altair products product portfolio, is starting from the FE structural and CFD validation. So you can see on the left hand side, so these are the solvers basically used, that OptiStruct, Radius, what basically mentioned the name of the solvers, and the application which you can cover, like strength and stiffness validation, fatigue, NVH, ride and handling, external aerodynamics, underwood and cabin flow. So that is all covered through FE structural and CFD validation. The next stage is the motor design and validation. So we have a dedicated platform name as Flux solver, where we have Flux motor as a motor design and simulation tool, where you can do the stator and rotor design, electric, and you can calculate the electric and magnetic losses. And further, you can improve the motor performance in terms of efficiency. You can calculate the torque ripple, you can minimize those, you can find out the motor thermal hotspots, where basically you want to see what is the thermal or temperature coming out from this motor while motor is running. Then also you can consider these electromagnetic losses to check what is the vibration generated by the motor. So all the things you can do with the help of these solvers, that is Flux, OptiStruct, MotionSol, and AccuSol. The next one is the battery design and validation. So for that we have AccuSol, where you can do the battery thermal management. So say for example, you have battery pack, and in that you have battery cell. So basically you want to see what is the temperature distribution on the battery cells, because the delta T, the temperature difference, is very important while designing any battery pack. So it should not go beyond 5 degrees Celsius. So that you can able to identify and modify your design by doing the battery thermal management simulations. The fourth one is controller system design and validation. So we have tools for that, starting with the Compose, which is used for the mathematical modeling. The activity is basically nothing but you can do a 0D, 1D, and 3D simulation. So where we have mechanical and electrical controls that you can include in your simulation, and further you can do a complete system level simulation. So again, once you do this system level simulations, so ideally this system level simulation comes in the format of block diagrams. So if you want to take hardware also into the consideration, so that block diagrams you need to convert into the C programming or Python, so that integration is possible with the help of embed. And the Polex is nothing but the tool, again we have acquired a couple of years back, which is used for PCB design and simulation. So we can check the signal integrity as well as power integrity. So it's a complete product portfolio we have. And last but not least, the data and intelligence and management. So where we have tool called as knowledge works data science, where you can do a predictive and prescriptive analysis for your battery life management and system connectivity. So all these technology disciplines we are covering through electric vehicle. Many of startup companies are right now associated with Altair and Design Text. So this year we have run a startup challenge, okay, where 350 startup companies has registered for this challenge, out of which we have shortlisted 50 companies where they are using our tools for the whole vehicle architecture level, as well as the system level like battery and motor design. So now coming back to the topic about Altair Radioss. So the first and most important thing is, as you know, the explicit uh, models or explicit run are very compute expensive, because whenever you want to fire a job for the explicit simulation, so generally it calculates the critical time step, and this critical time step is depending on the average element size or the smallest element you have used in your whole epi model. So if you have a complete vehicle level simulation, so probably you have million of elements, and that will actually hamper your solution time, in terms of it will consume a lot of time. So how to speed up the solution? So the Radioss is having the biggest feature is scalability. So what do you mean by this? So say for example, you have a hardware which is having 64 core, and probably you want to use your solver, explicit solver, to scale up to that number of cores. So Radioss doesn't have any limitation. So you can see this is the case study presented by the Ford, where they have used up to 2048 cores, and they have reduced a lot of time. And every version we have improved our this scalability feature, in terms of, you can see on the right hand side, we have started this scalability, radio scalability from version 13, where you can see on the x-axis the number of cores has been used, and on the y-axis the time required to solve the problem. So every version we have done this comparison, and current version 2021 is 30% faster than the past versions. So explicit runs taking a lot of time, so you can overcome this challenge by using Radioss, as it is scaled to in any number of cores. Even though there is a 50% performance improvement from version 13 to version 2021 on the same hardware. The biggest feature is the automatic domain decomposition. So what do you mean by that? I will explain in my next slides. So you can see one is the scalability. The next one is, say for example, if you are using the parallel processing or many number of cores, then repeatability of the results is quite important, right? So we have seen there are other explicit code which are very vulnerable if you are increasing the number of cores. But with the help of parity option, so basically this is an option available in Radioss which is default on. Okay, so once you submit any explicit job for Radioss, this parity option get on, and where you will get this repeatability of result. So accuracy of the result will not get compromised, even though if you increase the number of cores. So that is the meaning of this repeatability. So that is again a biggest feature of Radioss. So independent of the number of cores what we are using, you will get the same results. The third one is the advanced mask scaling. So there are certain features available in Radioss, so where you can use this option uh, to run the simulation faster. So what it does basically, it is actually adding a artificial energy in your job while running the job. So say for example, there is a deformation, and if the deformation is going certain limit, so generally in a normal run, the solution will not get converged, or you will get an error. So with the help of advanced mask scaling, this is adding some artificial energy, but of course you need to check what is the energy get added at the end of your run, because if this artificial energy get added more than the prescribed limit, then your physics is not proper. So with the help of advanced mask scaling, you can reduce the solution time, as well as you are not compromising on the physics. So that is the added advantage you will get with the help of this feature. The next one is we have sub modeling method as well. So say for example, you are running your full model. Okay, say for example a particular crash test, then it will take a lot of time. So to reduce that solution time, uh, you can use this submodeling method, where you can create a section. Okay, the main domain is there, and you are creating many subdomains, and we are running the subdomain, and where you are capturing the force and moment data on this section or section boundaries. And then further you can cross check it with your full vehicle run. Okay, if it is correct, then only you can go ahead and you can run the multiple iterations with these submodel options. So if it is not correct, then again you have to check the cross sections you have created. So this is the subdomain option is also available, or multi-domain I would say. So there are different terminology used as per the solvers, but we have this option available where you can create these subsections. You can generate the force and moment output on the boundaries of your sections, and then further you can do various iteration and verify your full final design. So that is what the process is available in our Altair Radioss. The next one is, you can see this is a case study from Ford where they have used this kind of approach. So where they want to see the battery design. Okay, the objective is to check the battery design, but if you run the full vehicle model and you want to include the battery subsystems or detail level battery subsystems, the battery cell and battery packaging, then it is very difficult to include all these details. So that's why they have used this multi-domain or multi-domain approach, where they have created a box like session while running the full vehicle simulation and capturing the crash simulation data on the boundaries of this box, and then further the battery core team use this data for doing the detail level analysis. So in that process they ultimately reduced 50% reduction in modeling efforts, as well as they reduce a lot of time. So these are the approaches we have to reduce the time to run the simulation. So one is number of cores, scalability, the repeatability. The third one is advanced mass scaling option, and the fourth one is uh, the multi-domain approach. The next key feature of Radioss is something, of course, any explicit simulation you run, you need to have various material model, because say for example you have a steel kind of material, and during the elastic limit, during the elastic limit there are certain deformation, but once it is crossed the yield and then there is a plastic deformation, so you need to consider that phase as well. So for that you need to use elastoplastic material model. So for all alloys, you are using elastoplastic material models. For the brittle, for the glass, for the composite, so you need to have these material models. Apart from that, you need to consider the failure criteria as well. So we have almost 300 plus material models, okay, starting from the elastoplastic to viscous, hyperelastic, for honeycomb, for fabrics, composites. So all the material models are available along with the rupture criteria library. So there are almost 300 combinations we have in Radioss, which you can use for uh, your complex physics simulation. These are the some of the specific material model used for automotive industry. So something you have, you want to check the failure of your windshield, so basically you need to have the particular model. So that material model we have, that is called as a fail alter. So this is basically failure model for glass. It is developed by Dr. Christian. Okay, then we have for the battery cell, we have again the failure material model available like SHAREI, so which is basically uses homogenization technique, so you can use it for your battery cells. So all these specific material models required by automotive industry we have. For the rubbers or hyperelastic material, we have various material model like Ogden, Munirevlan, Neoken, Aroda Boyas. All the material models are available, and these are the models basically used for tire industry as well as bushings. Okay, so all these material models are available. uh, this is again a unique feature with radio. So say for example user doesn't understand about these material models, so there are some predefined material models available in radio. So say for example I want to consider the elastoplastic, and then there is a steel as a mild steel material, so you will get the required parameters. So these are the predefined material models available, so that you can use at your starting stage. So once you are familiar with the radios, then probably you can check the particular material model, but that predefined material models are available for the initial users. Okay, so who just learn radios and they want to run the explicit simulation. So all these predefined material models we have, and again these models you are using it for various simulation, and you can see this scalability as well as repeatability we have checked for one of the cases. And you can see these are the almost 13824 cores being utilized for checking this predictive failure analysis of one of the structure. And you can see there is a lot of time saving. The next one is Altair is having windshield. If you want to see the windshield beer, okay, then you can use this failure Altair material. So here what we have did, so glass is modeled with the shell element and the PV foil is modeled with the solid elements. And uh, once the impact takes place, okay, so how the crack is initiating and how it is propagating, that you can able to check with the help of this failure material model. So we have checked it for outer layer as well as inner layer. Okay, so you can see the crack initiation as well as the crack propagation. Okay, so with the help of this fail alter model, and you can see on the right hand side, these are the fracture patterns. So actual head impact test, okay, the physical one, and the middle one is the experimental. Where left one is the experimental, the middle one is the exterior glass layer, and on the right hand side, interior glass layer. So there is a close comparison between the physical and virtual simulation. So solver accuracy is pretty good of Radioss, because ultimately the backbone of getting the accurate result, you need to have good quality FE model, and you can do this good quality FE model with the help of hypermesh. Then next come the battery cell analysis. So again, say for example, you have you want to develop your battery cells, and then these are the basically tests done for the battery cell testing. So you need to see the mechanical aspect as well as the electrical aspect, because if you do the compression test, indentation test, or 3-point bending test, so the mechanical deformations you are mapping, but there is a thermal runway, and because of that the power ratio get changed, so the electric property, so that also you need to map, because if this ratio get changed at from certain limit, so then probably there is a failure happen, there could be an accident in terms of fire or the explosion. So all these states you can able to do with the help of Radioss. So you can do the mechanical aspect as well as electrical aspects. So once you do the mechanical virtual simulation, you calculating the deformation, and further you are checking the thermal runway, and that you are using it for your uh, thermal simulation, and you can predict uh, the battery life or battery integrity, structural integrity. So you can see these are the tests we have did it. So one of the paper we have published along with the MIT battery research between 2016 to 2019, so where we have set up a complete workflow for this, where we are checking all the mechanical analysis as well as electrical analysis. And even though you can see these are the couple of tests we have did, the compression test and indentation test. So where you can see the experimental and results, where we have calculated the forces as well as the temperatures, and then the simulation results, where you can see the forces and temperatures, there is a close matching between the virtual and actual physical test. So apart from that, we have the process called as a composite delamination. For that you can use the our XFA method. So it's nothing but extended finite element method, where you can check the composite delamination. So where you are modeling your ply in hypermesh. So again you are using the formulation that is called as Batus, so which is again a full integrated element, and then you are actually considering the cohesive elements, where you can consider the gluing of these plies, and further you can check the sharing of these plies because of our delamination process with the help of this extended finite element method. So these are all advanced algorithms available in Radioss. Some of the benchmarks we have done with various organizations. So this is again a United States Automotive Material Partnerships, where they want to check the solver accuracy. So for that we have done couple of tests. So where we have run the virtual simulation, and they have checked the actual testing with the help of actual testing, and they are certifying some of the solvers for the typical crash test, bumper or crash test. So these are the some of the animation you can see on the left hand side, that these are the physical test and the virtual simulation. So there is a complete close correlation happen between the physical and virtual simulation. The next one is Altair Radioss for airbags. So again, from the safety perspective, so we have couple of methods available. One is finite volume method, another one is the constant pressure method. So both methods are available. So right, starting from the modeling of airbags, the folding of airbags, because the airbag folding is very critical, so that you can do it in hypermesh and hyper crash. And further you can use the various algorithm like finite volume method or constant pressure method, and you can predict how these airbag get deployed, whether my folding needs to be corrected. So everything you can check with the help of these methods. And again, this finite volume method is nothing but the pure CFD method, and that is included in Radioss. Okay, you can also check the flow inside the airbag, as well as you can check the interaction within the surrounding components. And generally, once you run the simulation, you are checking the velocities, gas velocities. You can check the temperatures, you can check the density, pressure, and this is a complete automated workflow. So you can either use hyper crash or hyper mesh for modeling of it. So these are the basically comparison we have done for the uniform pressure and finite volume method. So you are getting the quite accurate results with the both algorithms. So this is again a case study from passenger occupant safety simulation. SAE International, they have done it, where they have found the Radioss is quite a good solver for predicting this kind of simulation. The next one is Altair Radioss for manufacturing. So generally, if you see any automotive vehicle, the major components are stamped one, right? So they are using these components get manufactured with the help of sheet metal forming. So in sheet metal forming, the first you need to identify the blank size. So say for example, the forming the component, what is the feasibility analysis you are doing, where you are identifying the blank size and blank thickness. And then further, if you want to find out how many stages required to form this particular component, so then you are doing the incremental analysis. So Altair Inspire Form, which help you to do a forming simulation. And during this forming simulation, the generally residual stresses get developed, stress and strains. And if you not considering this residual stress and strain while doing the crash simulation, then probably you are approximating your predictions, right? So once you do the forming simulation, that residual stresses and strains you can consider while crash simulation. So that is the integration is possible in our interface, and you actually getting a better correlation, okay, with respect to test. So some of the case studies we have, there are many companies who are using our sheet metal forming simulation, and there are some of the OEMs which basically using this crash to form or inspire form to Radioss to getting the better correlation. The next one is something, even though we can use this manufacturing simulation data for the casting process. So where you can see this is a casting of aluminum rim, where you have check or identifying the casting defects, and further you are mapping those results for SORP test. So this is SORP test is nothing but small overlap rigid barrier test. Okay, so if there is any casting defect, you are identified during the casting process simulation, and then further you are taking into this basically SORP test. So you are actually considering the correct physics, where you will get the accurate results. So Inspire Cast is one of our manufacturing simulation platform, where you can check the casting feasibility and whole casting process simulation. The various smart workflows available for gravity die casting, high pressure die casting, low pressure die casting. So everything is available, and it's a very simple to use. And then the next one is the safety tools. So for the safety, we have again tie-up with couple of companies, that is Humanetics is again most of you are aware of it, which providing the physical dummies for the crash test. And the sail bond is nothing but providing the barriers, rigid barriers. Okay, so these two companies certified our solver Radioss, and they are providing the virtual they have certified our virtual dummies as well. So we have various dummies available. So adult dummies which are used for various simulation, whether it is a frontal impact, the side impact or rear impact. So various dummy models are available. So we have bunch of library for the child dummies. Also we have various models available for the various simulation like side impact, frontal impact, or crash simulation. Then this is are the various deformable barriers we have available, virtual barriers. So full width deformable barrier, where you are considering the 100% overlap. Then if you want to consider the 40% overlap, so these are the different barriers are available, and you can use it during your virtual simulation. This is for impactors, the head form, available, so which is basically the head impact test you are doing it. So these are the ready-made models are available which you can use it for simulation. Apart from the automotive, we have various dummy models for the railways as well as aerospace industries. So all these dummy models are available, and these are all certified dummies, virtual dummies, which you can use it for your simulation. So overall, I would say the Radioss is having a complete applications which cater to automotives, starting from the seat belt, dummy positioning, seat deformation, IP impact, crash and impact simulation, seat mechanism simulation, and due consideration of manufacturing feasibility. So it's a complete proven solver. And if I say why to choose Radioss, is because of these are the 5 points I would say. One is accuracy, so where you are getting the correct results because of hypermesh is a preprocessor, you are using it for generating the good FE model. The scalability, of course, the Radioss is scalable. IIT Kanpur is having a large clusters where they are using our solvers to reduce the solution time. The technical richness in terms of we have some unique and innovative features such as AMS, multi-domain, the finite volume methods for the airbags, XFEM, that is extended finite element method, and along with that we have optimization as well. So where you want to reduce the weight of your structure, so how to reduce the weight, we have certain algorithms like topology, topography, size and shape, so you can use it and you can reduce the weight of your structure without compromising the design constraint or design parameters. So optimization is enabled. And the quality, of course, the solver robustness, you are getting the repetitive results. And in every version we are adding new features, we are making our solver as well as our interface intuitive way where user doesn't have to bother about what is the cards required to solve a particular type of analysis. They can run it very faster with the help of this smart workflows. And uh, we again say that you can try to use our tools, so where we can help you in terms of doing the trainings, identifying the use cases, and we will support. So this is from my side. Thank you very much for your attentions. And if you want uh, to get trained on this tool, do not hesitate to contact us. So these are the contact details we have. You can either contact myself or Smita Kamble. Thank you very much. Thank you for your attention.
Thank you, Abhijit. Thank you for the technical insights on Altair Radio software. So we'll go ahead and take some time for the questions now. So just a little reminder, please be sure to type your questions in the question box in your control panel, or raise your hand to ask your questions personally. So Abhijit, we have a question from Mr. Raghuram. He's
Mhm.
asking, could you please explore more about predictive analysis of battery management?
Okay. So the battery management is nothing but, say for example, you have a battery cell or battery pack and you have some enough historical data. Okay, so where you have done various simulation, whether it is active cooling or passive cooling you have used to reduce the thermal temperature difference. Okay, so you have lot of historical simulation data, and further you have again a change in your design. So if you are changing the battery cell configuration or arrays, or even though you are changing the battery packs. Okay, so how to use this historical data, okay, for your predictive analysis. So for that we have a knowledge works as a platform where it is using this historical data. Based on that you can uh, use the machine learning model. So basically you are doing the decision trees. These machine learning models are inbuilt, where you are using the deep learning algorithm or the regression methods. And once you generate this machine learning model, probably from that you can do a business analytics. So basically without doing virtual simulation, if you are changing certain parameters, whether that parameters are correct or not, or you want to see what is the effect of changing these parameters, that you can do with the help of this data analytics or predictive analysis. Not only just predictive analysis but preventive analysis as well. Is it clear,
Okay.
sir?
Hope Mr. Raghu, we have solved your query. Please message us if you have further question on it. So Mr. Vittal has a question. He has raised his hand.
Mhm.
Mr. Vittal, you are self-muted. Please unmute yourself. Yes, Mr. Vittal.
Hello, can you hear me?
Yes,
Yes,
yes.
sir.
Yes.
Yeah, I'm basically from manufacturing production tool design. So
Mhm.
I'm very much interested in to know the simulation of the casting parts. Could you please
Okay.
explain me about that feature available in the radios?
Actually, it is not available in the radios, but something, say for example, if you want to do only casting process simulation, so you are, say for example, a supplier, okay,
Yeah.
to OEMs, where you are actually creating the components through casting process. So generally, you have various methods like the gravity die casting or the low pressure die casting, high pressure die casting. So Inspire Cast is a one of the manufacturing simulation platform available with us. Okay, the best part of this is something it required minimal input parameters. Okay, generally any casting process simulation software, it asks various parameters which difficult to identify, right, during the simulation. So it will ask minimal input parameters. We have a smart workflows for all these processes, and you can do a casting feasibility as well as casting process simulation. Once you identify these casting defects, and generally the porosity, say for example, okay, or maybe the temperatures, and then further you want to see during the crash as well, so what is the residual stresses or residual strain you want to take into consideration while running the structural simulation. The integration is possible, Inspire Cast and Radioss. So that is the option I have showcased you. But we have a separate solver platform available for casting process simulation named as Inspire Cast. We can do
Okay.
a detailed presentation on this as well. So if you are interested, so we can have one-to-one session where we can showcase you a complete demo on the tool.
Yeah, yeah, sure, definitely. Yeah. And could you help me to send, like, if you have any brochure kind of documents, we can you can share with us. I'll discuss with my team and I'll get back to you.
Definitely,
Yeah,
sir,
yeah.
definitely.
Thank
So
you.
Smita will contact you. Yeah, definitely.
Yeah, yeah. Thank you, Abhijit.
Yeah,
Thank you. Thank you so much. So Mr. Nishit Kumar has a question. Yes, Mr. Nishit Kumar, I have unmuted you. Please ask your question.
Yeah, it's Nitish Kumar here. I'm from Bangalore. I'm a CA analyst. Okay,
hmm,
I do work for our car technologies, and I use another solver. It's not
okay.
radios. Actually, I'm not
Mhm.
fully aware about the radios, but I wanted to know about the sub-modeling concept you said in this slide. Uh,
Right.
does it consider all the elements for the calculation, or how does it work in the sub-modeling concept?
Right. So generally, if you have a full vehicle model, right, and
Mm-hmm.
you are doing a different simulation in terms of frontal impact or side impact, okay, every time
Mm-hmm.
you cannot run the full vehicle model, correct,
Yeah,
to check
agreed.
the effectiveness of structural integrity. So
Mm-hmm.
where we have sub-modeling or multi-domain approach, where you are actually creating a section of your whole model. Okay, so generally you have a main model. Okay, so where you are
Mm-hmm.
considering the larger part, and there are some subsystems or sub-models, I would say. Okay,
Yeah.
and what is the use of that? Basically, you can change the mesh of these sub-models as well. So say for example, if you are run the sub-model with finer mesh, okay, you can
Mm-hmm.
actually take the forces and moment data on the boundaries of these sections. Okay, and during
Yeah.
while running the full vehicle simulation, you need not to consider the what do you say, detailing about the your subsystems. You can actually getting the force and momentum data during the full vehicle simulation. So ultimately you are reducing your whole model size, which will ultimately reduce your compute time. So these multi-domain and sub-domain approaches are available, and even though we have done the various benchmark to check the effectiveness of this sub modeling techniques. Okay, you are getting the same results. So once you are getting the same results, then further you can do a lot of iterations actually. So that is why
Mhm.
people are using this sub-modeling and multi-domain approach.
Yeah, understood. So basically, you are saying that instead of mesh size,
Mhm.
everything will be same, the material,
Yes,
cards, and all.
right, right.
So
So
the area of interest where it is there only we are creating the sections, and
right.
rest every model should be meshed as a course, right?
Right, course. And you are actually getting the data. So for the full vehicle simulation with the course mesh, you have run the simulation. You are getting
Mhm.
the forces and nodal data on the subsystem you are interested, and then further you can do a detailing. And ultimately, you are running for this multi domains. You are running the simulation for various time steps.
Yeah,
Yeah.
understood,
So
Abhijit.
that is
Thank
that
you.
is that we have a document for that as well. So if you are
Yeah,
interested, we will share with you. So
yeah, that
where
would
it,
be better.
yeah, yeah, yeah. So it will explain you the complete process.
Yes, perfect. Thanks.
Yeah.
Thank you, Nishit Kumar. Mr. Nilesh has some queries yesterday, so we'll just take his questions. He was asking how to apply impact load on a structure for crashworthiness analysis and what results can be drawn from impact structural analysis.
Okay, so for considering the impact load, there are various load inputs or load types are available in terms of either you can give the velocity, impose acceleration, impose displacement. Okay, that is one. Okay, once you given this input condition, and once you done the crash simulation, the results what you are checking is in terms of the displacement stresses. Apart from that, to check the accuracy of results, so once you are giving the initial velocity or imposed velocity to your structure, at the starting stage your kinetic energy is more, right? But once the impact takes place, the kinetic energy goes down or decreasing, and your internal energy get increasing. So you need to check the energy graphs: internal energy, kinetic energy, and total energy. There should be a energy balance. So that is how you can check the accuracy of your FE modeling as well as the solver.
Okay. He also added how to validate simulation results, stress, deformation, energy, etc. So,
Yeah, so that is one. So say for example, if you doesn't have any physical test data, then probably for the virtual simulation or virtual model check, you need to check the energy balance. But if you have physical test data, of course you can check the stresses of your virtual simulation and physical test with the help of strain gauge testing, or probably you are measuring the deformation by putting accelerometer, and you are actually measuring the data once, and then further you can check the effectiveness of your virtual simulation model. It's a
okay.
iterative process. Okay, so it's a iterative process, but for starting stage you need to have this process. You can reduce the physical test by getting the good correct FE model.
Okay. I guess he has something to add more. He has raised his hand. Yes,
Mhm.
Mr. Nilesh, I have unmuted you.
Yes, Abhijit, thanks for your information. Can you
Mhm.
elaborate us more this validation part? Like you said, the test results.
Mhm.
So let us say for the student MTech projects, if these test results are not available with us,
Right.
so can we take a simple rectangular beam and using a drop test, 1 ton load we can drop? Uh,
Mhm.
have you came across any validation, or how do you do this validation part in lesser budget or effective techniques, I will say?
Yeah, effective technique. So there is actually a complete process. So first of all, you need to have a correct material data. Okay, so correct material data in
So material
because
data, that means Young's models of elasticity and Poisson's ratio.
apart from that, as drop and impact is the explicit simulation, because the material goes into the plastic stage. So say for example, you are dropping your plate from certain height, say for example 1 meter or 10 meters, so something there could be a permanent deformation where the material goes from elastic to plastic stage. To consider that, you need to have a stress strain curve. Okay, that is one. If you don't have the stress strain curve, then you required to have Young's modulus, Poisson ratio, density, yield stress, ultimate tensile strain, and strain hardening parameter. With these two inputs, you will get the correct material data first. The next one is you need to mesh your model with good quality of element. Why? Because explicit simulation are very compute expensive. So the selection of the element type, element size is very important. Okay, so because ultimately it will calculate the critical time step which is considered by the solver. Okay, so once you have good quality of filament, actual material data, okay, then the correct input condition in terms of as you are doing the drop test. So generally it is you are applying the velocity, so the v is equal to root 2 gh. So gravity and actually acceleration, that is gravity you are considering as acceleration, and height you are calculating the velocity, and then you are defining the rigid wall as a your uh, the contact between the rigid wall and basically the component you have. That all the input condition once you define correctly, you will get almost correct results, 80% or 90%. You can improve it by changing the element size or element type and the various formulations, of course. So say for example, if you have used 2D mesh, so there are various formulations. So default the one point integration method you are using it, but say for example if you want to add more number of calculation points, so you can use the full integration element or um, parabolic element. So that you need to add. So it's a complete process, but something with this minimal input parameters you can validate your results. Apart from that, there are certain examples we have. If you go on Altair University, okay, where we have these validation examples, we have done it for various use cases, whether it is a static, a dynamic, frequency response, and for the explicit simulations as well. So you please visit Altair University, okay, and even though if you want more details about it, we will contact you, sir, or we can discuss it
Okay.
offline.
Okay. Yeah.
Yeah.
Yeah. I have your mobile email ID. So I
Yeah,
will see on the Altair University. Otherwise, I will come back to you.
sure, sir.
Thanks, Abhijit.
Yeah, thank you, sir.
Thank you, Mr. Nilesh. Anybody has any query, please type your query in the question box, please. It seems like we have covered all the questions. So still, if you have any queries related to the technology presented today or want to have a separate demonstration specific to your industry application, please get in touch with us. You have our email IDs. Lastly, thank you everyone. We appreciate you being here and joining us for today's webinar. Thank you so much once again and have a very nice day.